Welcome back to the deep dive. Today we're getting into the nitty-gritty of a pretty interesting piece of tech. It's the NTI E-LDA-LC2. And our goal here is to really pull apart the datasheet and figure out what this thing can actually do in the real world. The first thing that jumped out at me, and I had to read it twice, was the range. 1,640 feet.
Right.
For a liquid detector. That's almost a quarter of a mile from one little box. That's the huge aha moment right there.
It really is. This whole unit, the NTI unit, it's fundamentally designed for scale. It's a single zone detector, sure, but it's monitoring up to 500 meters of that sensor cable.
And that can be for water or chemicals or even those under carpet sensors?
Exactly. The sheer distance is what it's all about.
Okay, so let's say a leak happens 1,600 feet away down some, utility tunnel. How does this box actually tell you there's a problem?
Well, it gives you two things. It has an audible alarm, a loud sound, and it also has a visual one. A bright red LED lights up.
And I saw there's a mute button, so you can just turn off the alarm.
You can silence the sound, yes. But the red light, that stayed on until the leak is physically resolved. It's so the maintenance crew can come in, acknowledge the alarm, and work in peace without disabling the warning completely.
That makes sense. So with that kind of range and durability, is this something that's meant to, work all by itself?
Yeah.
Or is it designed to plug into a bigger building management system?
And that's its other big strength. It can do both.
Ah, okay.
It works perfectly as a standalone unit, but it also has these relay outputs for integration.
Yeah.
And what's really clever is how it mounts. It's din-rail mountable.
So it just slots right into existing industrial control panels.
Exactly. And for anyone learning about this stuff, the key phrase here is potential-free contacts.
Okay, let's unpack that. Potential-free. What does that mean in simple terms?
It's actually pretty simple. It just means the unit doesn't need its own power source to send a signal to another system. It basically acts like a light switch. It just opens or closes a circuit.
So it can talk to almost any other system out there, whether it's looking for an open or closed signal.
Precisely. It makes integration so much cleaner. And that idea of flexibility, it continues with the sensitivity. You can actually adjust the alarm threshold.
Why would you need to do that?
Well, think about it. You might be monitoring for pure water in one area, which isn't very conductive, and in another, a highly corrosive chemical. You can fine-tune the system to react perfectly to each specific threat.
Right, and that probably explains why it supports both the cheap, low-cost liquid detection cable and the really heavy-duty chemical one.
You've got it. You use the expensive stuff only where you absolutely need it.
And it seems built for tough places, too. I saw the operating temperature range. It's huge, -4 all the way to 122 degrees Fahrenheit.
Yeah, that tells you it's not meant for comfy air-conditioned server room.
No, this is for basements, rooftops, remote substations, places that get really hot or really cold.
Exactly. But we should talk about a limitation. A pretty big one, actually.
Okay, we know it's compact, runs on basic 12-volt DC power. What's the catch?
The catch is its digital brain, or lack thereof. The serial interface, the RS-485 network port.
Yeah.
It's not supported right now. It's on the unit, but it doesn't do anything.
Oh, so if your whole infrastructure is modern and digital, this thing is still speaking with, what, analog relays?
That's a great way to put it. You're relying entirely on those old-school open-close signals for any high-level networking.
Yeah.
It might require an extra step to integrate.
So to sum it all up for our listeners, what we have here is a system that's incredibly robust, offers massive range, and is super flexible, but you have to be okay with its reliance on that older, simpler relay signaling.
That's the long and short of it. And that brings me to a final thought for everyone to mull over.
Yeah.
So given this very specific combo long-range detection for both water and chemicals, in really harsh temperatures, think beyond the data center, what kind of critical infrastructure might absolutely depend on this exact mix of scale and adjustable sensitivity? Think about remote pipelines or maybe large-scale food processing plants. What are the implications of monitoring on that kind of massive granular scale?